All right, so you didn't have too much homework. Let me 1, 3, 5, 7, etc., etc. So I am going to start 2x plus 4. Hopefully, I picked some decent ones. So again, you can do that little story that you so much like or don't like. My variable is x times 2 plus 4, which means I'm going to do minus 4 on both sides and then divide by 2. No negatives, so I don't have anything to worry about in terms of switching signs of my inequality sign. So minus 4, let me put a bar here. Minus 4, we get 2x is greater than 20. Divide both sides by 2, and x has to be greater or equal to 10 to make this inequality true. Graph. Oops. So number 10, 11, 12, a couple numbers on each side, usually enough. Circle on top of the 10. I want to shade it because 10 is part of my solution. Remember, there's an equal sign here. Point the arrow that way. So pick any number going that way. So my check, so I'm going to pick a value for x, and I'm just going to keep it very simple. X equals 10. Here's my original inequality. I'm going to replace that x that you see with a 10. So I'm going to go 2 times 10 plus 4 greater or equal to 24. And you can see that it does hold true. 24 is not greater than 24, but 24 is equal to 24, so we are good. Okay, it's just that simple. 3 has a little bit of, oh, the 3 property, wow. Less than negative 18. So we have to do 3 property first. Let's get rid of that. Minus 3 less than negative 18. Again, story. Variables p times negative 3 minus 3. Going backwards, I'm going to do plus 3, and I'm going to divide both sides by negative 3, and I'll put a little star, because that means I'm going to have to switch signs when I get to that point. So plus 3, plus 3, those goes away. Negative 3p comes down, less or equal to negative 15. So now our second step, is to divide both sides by negative 3. Divide this by negative 3, and divide this by negative 3. So hopefully you remember what we talked about in class. So if we're dividing by a negative number, the inequality sign goes the other way. Negative 5 divided by 3 is positive. That's positive 5. Okay, so when you divide by a negative number, make sure you switch the signs. Graph 5, 6, 7, 4, 3. We want the inequality to point to the right. So again, one of the reasons I like my inequality, my variable on the left side. So when the variable is on the left side and I want to point my arrow now, all I gotta do is look at my inequality. My inequality is pointing to the right, and that points to the right. And that only works if your inequality is on the left side. Okay. So I'm gonna pick 5, 6, 7. Let's pick 10 just for, so check. Let's make p equals 10 just for argument's sake. Let's pick a different number. So substitute. So here's my original inequality. I'm going to replace the p with 10. So 10 plus 1 is 11 times negative 3. 3 times negative 11, negative 33. Is negative 33 less than negative 18? Remember, these are negative numbers. 1 second, please. Okay, so if you don't know if that's true, get a number line. Put 0 over here. Negative 1. So keep going. Find negative 18. Find negative 33. Who's on the right side? Negative 33 or negative 18? Negative 18 is on the right side. So remember, on the number line, the number on the right side is always the bigger one. So this statement holds true. 5, negative b minus 2 greater than 8. So this is this problem here. I like when my variable is negative, I like to put a 1 here, and I'll show you why in a second. Okay. So it's negative 1b minus 2 greater than 8. So here's my variable b. What's happening to it? Being multiplied by negative 1 and then subtract 2. I'm going to do plus 2 and then divide by negative 1. So again, put a little star. Remember, we're dividing by negative numbers. So let me write that a little bit better. So first thing we do, change colors, plus 2, plus 2. A plus 2 is 10. This goes away, and negative 1b. Now, the next thing I have to do is divide both sides by negative 1. Negative 1 divided by negative 1 makes this is going to turn positive, which is what I want my coefficient, my variable to be. B has to be positive. And then switch signs because we divided by a negative number, and 10 divided by negative 1 is negative 10. The only reason I put, and then let's say I didn't put the negative 1 over here, okay? It would look like this. And some of you might say, oh, I don't know what to do, it's negative b. How do I get rid of that negative sign? Okay, so it's easier to see when you have a coefficient of 1 here. If you put a coefficient of 1, oh, now I have to divide both sides by negative 1, and that's how you would turn this negative b into a positive b. Okay, so it just makes it easier for you to see. So number line, here's negative 10. Be careful with your number line when your numbers are negative. Shade, we're not going to shade. And we want numbers that are smaller than negative 10. So again, I told one of you guys to do that 1000 test. Put 1000 over here. Is 1000 smaller than negative 10? Obviously not, right? So where is 1000? 1000 is on the right side, right? So if it works, if you put the 1000 in the inequality, substitute it, and it works, you point it this way. If it doesn't work, you point it this way. In this case, when you substitute here for 1000, is 1000 less than negative 10? No. So because it didn't work, we want to point it that way. So now, we're going to come to the check. Let's copy the original equation. So it's negative b minus 2 greater than 8. So we can pick negative 11, negative 12, negative 10.5. Let's not use decimal, so let's just use negative 11. So let's pick b equals negative 11. That's the value that we chose. Substitute. Here's a substitution. You have to be really careful. That minus sign was already there, and I'm going to take the b out, and I'm going to put negative 11. So that's what your substitution looks like. And then minus 2 greater than 8. Notice that I took the b out and replaced it with negative 11. Okay, so now we have these two negatives together. Negative and negative is a positive, so we get 11 minus 2 greater than 8. Positive 11 minus 2 greater than 8. 11 minus 2 is 9, and is 9 greater than 8? Look at that. Our inequality holds true. So we're doing something right. 7, we have a 4 plus n divided by 3 less than 6. Again, what is my variable n is being divided by 3 and then plus 4. So I'm going to use minus 4, inverse operation, and times 3. So let's do that. So the first thing I'm going to do is minus 4. Minus 4, minus 4. N over 3 comes down. 6 minus 4 is 2. That's done. Next thing I'm going to do, I'm going to multiply both sides by 3. Positive 3. So I don't need to change the signs the other way. Okay, equality sign doesn't need to point the other way. So this 3 and this 3 simplifies to 1. 1 times n is n, and 2 times 3 is 6. So there's my answer. 6, 7, 8, 5, 4, arrow, arrow, circle on top of the 6. We want numbers less than 6, and they are this way. And notice again, where's my inequality pointing? It's pointing to the left, and so does my arrow. Okay. Let's pick a number. So we're going to do a check. So we can pick 5, 4, 3, 2, 1, 0. I like 0. I can pick 0, I will pick 0. So I'm going to say n equals 0. My inequality was 4 plus n divided by 3 less than 6. So when I replace the n, it's going to look like this. 4 plus 0 over 3 less than 6. Well, 0 over 3 is just 0, and 4 plus 0 is just 0. So we got 4 less than 6. Beautiful. You will love the zeros in the future in terms of values for variables. 9, we have something a little bit more challenging. 56, yeah. Okay. Variables x is being multiplied by -7, add 7. So the two inverse operations I'm going to use, I'm going to subtract 7 first, and then I'm going to multiply by -7. Little star here. So -7, -7. That goes away. -56 and -7 and -63. And now I have -7x. So the next thing I have to do is divide both sides, and sorry, it's hard to see, divide both sides by -7. So I'm going to divide by -7, divide by -7. Remember, dividing by -7 automatically makes the sign go the other way. That becomes x, and this becomes 9. So x has to be greater or equal to 9. 9, 10, 11, 8, and 7, 0, no, sorry, 0 circle. We want numbers greater or equal to 9, so 9 is shaded because it's part of my solution, as well as every number that is to its right. Let's pick an easy number. Let's just pick 9. Oh, you know what? Let's pick 100 just to be crazy. I don't know. So check. We're going to x equals 100 because we can. So -7 times x plus 7 less or equal to -56. That was my original inequality. I'm going to place -7 times 100 plus 7. So let me change color. So -7 times 100 is -700. Plus 7 less or equal to -56. These two, -7 plus 7 is -693. And is that smaller than -56? For sure. Okay, so inequality holds true. One last question. Here we go. -11x, oops. -11x minus 4 greater than -15. Okay, so if I'm reading that correct. Variable is x, which is currently being multiplied by -11. Subtract 4. Inverse operation is going to be plus 4 and divide by -11. Okay, so little star to remind you that we need to switch the sign when we get to that point. All right, so step 1. Plus 4, plus 4. If we do that, -15 plus 4 is -11. These two go away, and -11x comes down. I divide, let me change colors, divide by -11, divide by -11. So this and this becomes 1. 1 times x is x. The sign has to switch from greater than to less than, and -11 divided by -11 is 1. Graph it. So circle on top of the 1. Shade, no, because 1 is not part of the solution, and we point that way because we want every answer less than 1. So, and notice that we have my favorite number, 0. So 0 is part of the solution, so I'm going to check. I'm going to pick one of the values, and this time I'm going to pick x equals 0. And I'm going to substitute. So here's my original inequality. So I'm going to switch the x with 0, so I'm going to go -11 times 0 minus 4 greater than -15. Well, -11 times 0 goes away, right? So I'm left with -4 greater than -15. So is -4 greater than -15? Yes, it is. So, again, our inequality holds true. And that's it. Hopefully, you had an easy time as well. Okay?